Welcome to MyProjectBazaar.com. Now we are going to discuss about the project depth-attentional features for single image rain removal. Now we are going to discuss about the abstract of the process. In this process we addresses a rain removal problem from a single image even in the presence of heavy rain and then the rain streak accumulations. Our core idea lie in the new rain image models and then a novel deep learning architectures to remove the rain streaks from the image. We first modify an existing model comprising a rain streak layers and the background layers by adding a binary map that locates the rain streak region separately. By using this binary map, we can exactly identify where the rain streak is present, where the rain streak is not present. So second, we create a new model consisting of a component representing the rain streak accumulations where the individual streaks cannot be seen and thus the visually similar to mist or fog, and another component represents the various shapes and directions of the overlapping the rain streaks which usually happen in the heavy rains. So we have to segregate the background and then the foreground separately. Foreground is the rain streak region, background is the other regions like objects. So after that we have to apply the raindrop removal techniques to remove the rain streaks from the image. Then the output will be in the quality image. Finally, the performance of the process will be evaluated based on the PSNRs and MSE to estimate our process is efficient or not. Now we are going to discuss about the overall working flow of this process. This is the overall working flow. Hence this process having the modules such as the image acquisition, pre-processing, segmentation, rain streak removal, then finally the performance estimation. At first the image acquisition. The input image is taken from the dataset. In this dataset there are several rain streak images are there. After getting the any one image from the dataset, we just move on to the second stage of the process, that is the pre-processing. In this pre-processing we have two kinds of pre-processor is there. One is the image resize, then the another one is the color conversion method. In this resize we have to resize the image into an aspect ratio of changing the dimension of the rows and columns. After changing the dimension of row and column, we have to do the color conversion methods to find out where the exact rain streak is present or not. At first, initially it will predict the color variations between the rain streaks and then the normal region. After estimating the rain streaks region, we have to do the segmentation steps. In this segmentation step, finally the rain streaks regions will be extracted separately and then the other regions without having the rain streaks will be extracted separately. That will be considered as an background and foregrounds. So the background is the unwanted regions, the foreground is the required regions. Hence in this process the foreground will be the rain streak images, so it is the required regions to extract. And one more thing, it have to remove by this using the process. So for removal we have a next stage of the project, that is the rain streak removal process. So we have three kinds of rain streak removal process here. One is the median filter method, then the another one is the Gaussian filter method, then the third one is the collaborative method by combining of the above two methods. So by using these three methods we have removed the image rain streak image from the image. Then after the rain streak removal we just move on to the final stage of the project, that is the performance estimations. In this performance estimation we have three kinds of performance estimators. One is the PSNR, then the another one is the MSE, then the third one is the time. As usual you know about the time. The time is means how much of the time taken for executing the overall process. Then PSNR in the sense peak signal to noise ratio. Then MSE represents the mean square error. Now we are going to discuss about the initial running procedure of the process. At first open the MATLAB 2015B and then change the current directory. Now if you want to execute the process, just right click in the main file.m and select the option run. Now you can see the several images having the range streaks. Now I can select any one image from the dataset and then click the button open. After the selection of the input image from the dataset, the process will be getting to execute one by one. After the overall execution, I just explain the concept one by one. Now this is the figure 1, which represents the input image which I have taken as the dataset image. So in the title of input image, after getting the input image from the dataset, we just move on to the second stage of the project, that is the image resize. You can see the difference between the input image and then the resized image. Totally the dimension of the image will be changed. Then the third stage of the project, that is the YCBCR. This is a kind of the color conversion. There are a lot of color conversion is there, like lab color conversion, chromiums, lot of color conversion is there. So among that we are using the YCBCR color conversions to convert the RGB image into an YCBCR color transformations method. So after the color transformations, we are using to detect the range streaks regions. You can see the difference between the resized image and then the detected regions, in that the range streaks regions will be highlighted like this. Then raindrop removal. So in this raindrop removal, you can see the difference between the original image and then the raindrop removed image. So in this original image, the range streaks will be visibly available. In this the raindrop removal image, the range streaks will be eliminated. Only the objects will be clearly visible. Now in this figure, I hope you can understand better. So this is the rain image. This is the initial removed, but the image is somewhat blurred, so we have to apply the final removal method to remove the image, as well as the quality of the image will be retained originally. Finally, performance estimations. So for every process we have to find out the performance estimation. Here we have to find out the performance in terms of PSNR, MSE and entropy, as well as the time taken. So here the PSNR value is above 40 to 45, so that is the enough. The MSE will be very low, only around 1.2. Thanks for watching this video.